Today we're going to look at lessons 8.1 and 8.2. And in this first lesson, we're going to be graphing f of x equals ax squared. Now, this is what we are calling and referring to as the parent function. All right, the parent function. So in a little bit, we're going to see this again, and we're going to actually add this to our notes because we want to make sure we understand this is what is considered the parent function. Now, so far, we have looked at linear graphs and we've looked at exponential graphs. Can somebody raise your hand and describe for me what a linear function or a linear graph would look like? Josh?
A line.
A line. Okay, that one's pretty simple. What about an exponential graph? If we have an exponential function, what did the exponential graph look like? Remember when we did our growth and decay problems? What did those graphs look like? A curve, like a banana shaped almost is what we called it. So we've learned we should be able to identify just from looking at a graph, this is linear, this is exponential. Well, today we're going to look at quadratic. Okay, quadratic functions are those functions that have an x squared in them. Okay, it can be x squared all by itself, it can be a binomial, it can be a trinomial, but if it has an x squared in it, it is a quadratic function. So the essential question for today, what are some of the characteristics of the graph of the quadratic function of the form f of x equals ax squared? Well, we need to know what a quadratic function looks like. We know what a linear function looks like. We know what a exponential function looks like. Now we're going to learn what a quadratic function looks like. So every quadratic function has a U-shaped graph called a parabola. All right? So this is called a parabola. Now, you'll notice I gave you two different kinds of parabolas. What do you notice about this first one as far as which direction it opens? Up or down? Right here it is. It's right here. Is that opening up or down? That is opening up. Okay, that is opening up. This parabola over here is opening down. Okay, this one opens down. So there's parabolas that open up and there's parabolas that open down. Now, here are the characteristics that you need to know. So grab a highlighter and let's highlight these four words. Vertex, axis of symmetry, domain, and range. The vertex is the highest or lowest point on a graph. Now, I want to point this out. A point is an ordered pair. So when it says the highest or lowest point, just understand the vertex is always going to be an ordered pair. But when we're talking about the highest or lowest point, that kind of takes us back here to when we talked about whether this graph opened up or down. Okay, it's not going to let me go back, so sorry. All right, so remember we talked about the graph opening up or down. Well, if the graph opens up, it has this low point down here, okay? If the graph opens down, it has this high point. That is called the vertex, the highest or the lowest point on your graph. All right, then you have the axis of symmetry. Now this one I'm going to try to explain and hopefully it's going to stick with you. It's a line that passes through the vertex that divides the parabola into two symmetric parts. Now I know you know what symmetry is because you learned it in second grade. How do I know that? Because my second grader has this on his math papers, all right? When something is split down the middle, if it has symmetry, it's the same on both sides. So that's what's happening. The axis of symmetry is going right down the middle of the parabola, right through the vertex, and it's splitting it into two sides that are equal. They match. They're mirror images of each other. Okay? But here's what you have to understand. It's a line. And if the axis of symmetry is a line, the answer is an equation. All right? Everyone kept trying to give me values. I say, what's the axis of symmetry? They say 1. They say 3. No, the axis of symmetry is a line. So the answer is x equals 1 or x equals 3. The answer has to be an equation because the axis of symmetry is a line. Now, we've got domain, which we've talked about. Here's the easy thing about parabolas and your domain. It's all real numbers. There's nothing that x cannot be. So the domain is going to be all real numbers. Now, the range is going to take a little bit of thought, but it's actually probably one of the easier ranges that we've learned. Range has to do with the y values. So y is either greater than or equal to something, or y is going to be less than or equal to something. What do you think that's going to be based on? How are we going to know if it's greater than or equal to or less than or equal to?
opening up or down?
Very good. Does the graph open up or down? That's how we're going to determine if our range is greater than or equal to or less than or equal to. Good job, guys. All right. So let's just start. Let's look at a graph. They've given us a graph, and we are going to identify the characteristics. Now, what are the 4 characteristics that we just highlighted in our notes? The vertex. So we're going to go ahead and underneath both of A and B, we're going to write vertex because we know that we're going to identify the vertex. All right, what was the second piece of information we talked about? The axis of symmetry. So let's go ahead and write underneath each of these, let's go ahead and write axis of symmetry because we're going to find and identify the axis of symmetry for both of these. All right, what was the third characteristic we talked about? Domain. So we're going to find the domain of each of these. And what was the fourth characteristic? The range. Very good. So we're going to go ahead. We're just getting a little bit ahead of the game. And we're writing down the 4 characteristics that we're going to find. Now, this parabola, is it opening up or down? Down. So hopefully we can quickly find the vertex. Now remember, the vertex is a point. So when you give me the vertex, I'm looking for an ordered pair because points have ordered pairs. All right, somebody raise your hand and tell me the vertex of this parabola. Deja? Very good. Negative 3, 7. If you go left to negative 3 and up to positive 7, you get the ordered pair negative 3, 7. And that definitely is the highest point on this graph. Now, the axis of symmetry, by definition, is a line that passes through the vertex. So before we actually identify it, let's draw it. If we draw a line that goes right through the center of the vertex, what kind of a line are we looking at? It is definitely straight, but is it vertical or horizontal? Vertical. It's vertical. So a vertical line passes through which axis? X. So that means when we go to write the axis of symmetry, it's always going to be X equals something. Because the axis of symmetry will be a vertical line. So now the question is, what does X equal? Well, what value does that line cross on the x-axis? Negative 3. Now, do you notice anything about the vertex? Raise your hand. Notice anything about the vertex and the axis of symmetry? Yasmin, what do you notice? What are the same? The x value. The x coordinate of the vertex and the axis of symmetry are the exact same value, and they will be every time. Okay? Let me say that again. Sometimes you guys say, will it always be that way? This is a yes, most definitely. The x coordinate of the vertex and the axis of symmetry will be the same value every single time. Now, what's the domain? This one should be easy too. All real values, okay? We know this, or all real numbers, sorry. We know this because there are arrows on our parabola. And if there are arrows on our parabola, that parabola goes off in both directions forever and ever and ever. So we have no idea what negative x value or what positive x value it's going to end on. So it is all real numbers. Now the range, let's talk about the range. The range deals with which set of values, x or y. So we know y's in it. Now, what is the highest y value on this graph? And I'm asking for the highest because this graph opens down. So that vertex is the high point, right? So the highest that graph reaches is definitely 7. So 7 is the value in our range. And now all we have to decide is it y greater than or equal to 7 or less than or equal to 7? Okay, why is it less than or equal to? Okay, the parabola opens down. So every other y value is going to be lower than 7. Now, what do you notice about the vertex and the range value? What do you notice about the vertex and the range value? Okay. The y coordinate of my vertex is also the value in my range. Okay. So look at this. You've been asked to find 4 things and they're all intertwined in that vertex. If you can find the vertex, you can also find the axis of symmetry and you can find the value in your range. All right. So recognize how simple it actually is. All right, let's do letter B real quick. What's the vertex? Very good. Right here you see, and you got 2, -3. What is the axis of symmetry?
X equals 2.
Good job. All right, we would draw our line. But even without drawing our line, we would see that the x coordinate is 2. So the axis of symmetry is x equals 2. What's the domain?
All real numbers.
Good. All real numbers. And Trevin. Everybody write down the range. But Trevin, you tell me what the range is going to be.
Y is greater than or equal to just 2. I mean, -3.
Very good. All right. Y is greater than or equal to this time because my parabola opens up, and the lowest y value is that -3, okay, which comes right from the vertex. It's the y coordinate of the vertex. So this would be my final answer. All right. And I'm so sorry I forgot to box in letters A's final answer as well. Now, in example 2, we actually have to graph the function, or we're going to let Desmos graph it. So go ahead and grab your phones, open up to Desmos, and let's talk about something real quick. All right? Are we going to be able to plug g of x equals 5x squared into Desmos? Is it going to recognize g of x? No. So what are we plugging in place of g of x or q of x? Y. So don't forget that, okay? It's not going to recognize the g of x, so you got to replace it with the y, which they're interchangeable. So that's totally fine, all right? So go ahead and plug it in.
So Y then.
Now, when you graph, here are the things I want you to graph, all right? This is new. We've never graphed parabolas, so if you want to make extra notes, make extra notes. I want the vertex on your graph. I want the axis of symmetry. We're going to make it a dotted line, but I want the axis of symmetry. And I want 2 more points, one on either side of the axis of symmetry, all right? So that's what you're looking for. Now, you don't have to graph the axis of symmetry on Desmos. You can do that on your paper, all right? But at least make sure you're finding the vertex and 2 points, one on either side of that axis of symmetry. So when you graph letter A, what was the vertex? Vertex is 0, 0. So it's right here in the center. All right, what were some points that you found? Exact points. We're not guesstimating. I want exact points that are on this graph. Say it again.
-1, 5.
All right, -1, 5. So left to -1 and up to 5. And what's a point on the other side of the vertex? How about 1, 5? Very good. Now, what's the axis of symmetry? Because we have to graph the axis of symmetry, so it's going to go where? Right down 0, okay? It's going to be right on the the y-axis because our vertex is 0, 0, okay? But it is part of what we're going to be graded on when we graph a parabola. The axis of symmetry must be there. And then the last thing we have to do is draw the parabola. Make sure it is U-shaped. A V-shaped graph is a totally different type of graph. It's an absolute value graph. So make sure you're very, very careful that this is curved, and make very sure that you have arrows on the end. Okay, you have to have arrows on the end of your parabola. But this is what I'm looking for. Axis of symmetry, vertex, 2 points on either side of the axis of symmetry. I keep saying cemetery. I don't know why. Sorry. And arrows on the end of your parabola. All right, what about letter B? Do you have a vertex yet for letter B? 0, 0 again? All right, now this one's a little bit more difficult. We gotta look a little bit further, a little bit wider to get some exact points, but it can be done. All right, what are some exact points on this graph? So left to -7 and down to -5, and then I got one at +7, -5. So right to 7 and down to 5. Are you guys seeing that on Desmos?
Yeah.
Okay. Remember, you want exact points, so you're going to have to look a little bit further. Now, the axis of symmetry, again, right down the center, because our vertex is 0, 0, but we're still drawing it. We're just going to draw it a little bit darker than the y-axis. All right, and when you draw that parabola, be really, really careful that it is curved and not a V. Put your arrows on the end and make sure those points are super obvious. All right? Any questions? All right. Now, example number 3. Example number 3. Compare the following equations to the equation of f of x equals x squared. So again, this right here is what we call our parent function. So as we try to figure out the transformations that have taken place, we want to first try to identify and look and find our parent function. So look at letter A and tell me, can you see the parent function within this problem? The parent function is x squared. All right, so do you see in letter A x squared?
Yes.
Yes. Okay, great. So this is now going to help us to figure out what has been done to the parent function. How many things have been done to this parent function to change it?
Maybe 3.
Okay, but how many things is that? You've got a sign now, you've got a sign change, and you've got a 3. So how many transformations have taken place to this function? 2. Okay, the negative sign is one transformation. The 3 is the other. So now we've got to figure out from our cheat sheet what each of those represents. What type of transformation? So which transformation deals with a sign change? A reflection. All right, awesome. So we're going to go ahead and we're going to write down reflection. We know it's a reflection. We just don't know yet if it's across the x-axis or the y-axis. But we definitely know it's a reflection across something. So we're going to write that down. Now, the question has to be, have they changed the sign of f of x or just x?
Just f of x.
Remember, we talked about this at the very beginning, so we wouldn't confuse this. If they've done something to just x, they're inside a set of what? Is there parentheses anywhere in this problem?
No.
So there's no way they've done something to just x. They would be in parentheses with x, doing whatever to x. Okay? There's no parentheses in sight. So let me ask that again. Have they changed the sign of f of x, or have they changed the sign of just x?
F of x.
Of f of x. So looking at our cheat sheet, is that a reflection across the x-axis or the y-axis?
X.
That's a reflection across the x-axis. I'm looking at my cheat sheet. I see a negative sign in front of f of x, and right beside it, it says reflect across the x-axis. Okay? So that's a reflection across the x-axis. Now, the 3. We gotta understand, are they adding, subtracting, or multiplying it? They're multiplying it. So which transformation deals with multiplying by something? A shrink or a stretch. Okay? Now we've got to decide. Are we multiplying f of x or are we multiplying just x? Okay, we are multiplying f of x. Again, there's no parentheses. They haven't gone inside with x and multiplied just x by anything. They've kept f of x. Does everybody, maybe this is what's confusing. F of x equals x squared. So you're ultimately asking yourself, are they multiplying x squared by 3 or are they multiplying just x? And clearly they're multiplying x squared by that 3. So if they're multiplying f of x, it's vertical or horizontal? So this is vertical. They are multiplying f of x, so we know it's vertical. And now we just have to decide, does my 3 fall between 0 and 1, or is 3 greater than 1?
Greater.
So if my a value of 3 is greater than 1, is it a stretch or a shrink? It's a stretch. So this is a vertical stretch by a factor of what?
3.
By a factor of 3. Okay, remember, we like vertical stretches and shrinks because the factor is exactly what we see. So there are the 2 transformations that have taken place to that problem. All right, what about letter B? How many things have been done to this x squared, this parent function? 1. And they are doing what with 1/3? Adding, subtracting, or multiplying? Multiplying. So that takes me down to which transformation? Stretches or shrinks. Awesome. So are they multiplying by f of x or are they multiplying by just x?
F of x.
F of x. So is that vertical or horizontal? That's vertical. Awesome. So now we just got to decide, is it a vertical stretch or a vertical shrink? So take A, which in this case is what? 1/3. And does it fall in the category of being greater than 1 or does it fall between 0 and 1? So is that a stretch or a shrink?
Shrink.
That is a shrink. So this is a vertical shrink by a factor of, there we go. And we boxed it in. All right, now we are given a graph in letter C. Which one of those is the parent function? The black parabola or the blue parabola? Black. So h of x equals negative 1/3 x squared is the function that we are looking at for the transformation. All right, how many things have been done to x squared this time? 2. We've got a negative sign and we've got a 1/3. So a sign change is what transformation? A reflection. And if it's did it change the sign of f of x or just x?
F of x.
So the reflection across which axis?
The x.
The x-axis. Good. All right, 1/3. Are they adding it, subtracting it, or multiplying it? They're multiplying, so that takes me down to the bottom of my cheat sheet. I know it's a stretch or a shrink. Are they multiplying f of x, or are they multiplying just x?
F of x.
So that makes it vertical. Good. And what is my a value this time? 1/3. So where does that fall? Is that greater than 1, or is that between 0 and 1? So that makes it a vertical shrink by a factor of, no, remember the negative is its own thing. It's a reflection. Okay? So by a factor of 1/3. Very good. Now that takes us into 8.2. Okay, that takes us right into 8.2, which if you notice, the lesson title is graphing f of x equals ax squared, which we just got done with, plus c. Now, if we're adding something to the end of our function, if we're adding something, which transformation is that on our cheat sheet? If you're adding something to the function, what transformation is that on our cheat sheet? We've already dealt with multiplying by something, so we know it's not a shrink or a stretch. We've already looked at changing the sign, which is a reflection. So what's the only transformation left that we haven't really dealt with yet? Okay, we don't call it a shift though. We call it a translation. All right, on our cheat sheets, we crossed out shift and we put translation. So how does the value of C affect the graph? That's our essential question. And we're continuing with example 3. We're going to keep on comparing these functions to the parent function. So look at letter D. How many things have been done to the parent function?
2.
What are they? Just 1, right? We've got the x squared, which is the parent function. The only thing that's been done is they've subtracted 5. So, subtracting is what kind of a translation?
No.
We're subtracting 5, which is what kind of a transformation? Not a shift. We call it a translation. All right. So the question is, are they subtracting from f of x, or are they subtracting from just x?
Just
F of x. Again, if they were subtracting from just x, they would be in parentheses with just x. Okay. So is that horizontal or vertical if they're subtracting from f of x?
Vertical.
Okay. Vertical. Right? If I'm looking at my cheat sheet, it says f of x minus k, which is exactly what's happening here, and that's a vertical translation. The translation, we have to say what direction and by how many units. So this is a vertical translation in what direction? If it's minus 5. Down. How many units? 5. Very good. 5 units. All right, now letter E. How many things have been done to this parent function? 3. We've got a sign change, we've got a 1/4, and we've got a +4. So very quickly, the sign change makes it a what? A reflection. Did they change the sign of f of x or just x? F of x, which makes this a reflection across what? The x-axis. Good. All right. The 1/4. What are they doing with the 1/4? They're multiplying it. And is it greater than 1 or is it less than 1? Okay, and are they multiplying it by f of x or just x? F of x. So that makes it a what? A vertical, because they're multiplying it by f of x. 1/4 you said was falls between 0 and 1, which makes it a vertical shrink by a factor of 1/4. All right, and then we've added 4 to the end of the function. So what transformation is that? That is a translation, but what kind? If it's added to f of x, is it horizontal or is it vertical? It's a vertical translation. Up 4 units. Awesome. Good job, guys. All right. Now, letter F. Which one is the parent function? The blue parabola or the black parabola? The black. So we're looking at, right here, we're looking at g of x equals what? 4x squared plus 1. How many things have been done to this problem? 2. All right. Stick with me. We're going to finish this. All right. They are doing what with the 4? Multiplying it. And are they multiplying it by f of x or just x? Which makes it a what? A vertical. 4 is greater than 1. So a vertical stretch. Okay. By a factor of what? Good. And they've also added 1. So that is what kind of a transformation? A translation. What kind of translation? Right, vertical or horizontal? They've added 1 to the f of x. So it is a vertical translation. What direction? How many units? Up 1 unit. And that is lesson 8.1 and 8.2.